Hello everyone, I'm Mansi. I'm from Sri Venkateswara College of Engineering. So today's topic is representing knowledge in uncertain domain. Let's start the video. So in this video, I'll discuss about the introduction, what are the challenges, what is probabilistic models, and what is fuzzy logic for handling uncertainty, and artificial intelligence approaches for uncertain knowledge representation, and what is evaluation and validation, applications and conclusion. So let's start with an introduction. So introduction to representing knowledge in uncertain domain. So uncertain domain refers to various areas where there is incomplete or unambiguous information. So advanced artificial intelligence systems need to be able to handle uncertainty in order to make accurate decisions. So, representing knowledge in uncertain domains is essential for artificial intelligence systems to effectively operate in real world scenarios. So, what are some of the challenges that are used or in representing knowledge in uncertain domains? First is uncertainty arises due to limited data and conflicting information and changing circumstances. And second challenge is representing uncertainty requires capturing probabilistic relationships between variables. So the third challenge is balancing the trade-off between accuracy and efficiency in major challenges in uncertain domain. So, what is probabilistic models for representing uncertain knowledge? So, first is Bayesian network. So, Bayesian networks are graphical models that uses directed acyclic graphs to represent probabilistic relationships among a set of random variables. So, they are widely used in uncertain knowledge representation in various fields such as healthcare, finance, and natural language processing. And Bayesian networks allows modeling dependencies between variables and make probabilistic interferences based on observed evidence. So second is Markov decisions. Markov networks are undirected graphical models that is used for representing probabilistic relationship among variables. So they are used in situation where Bayesian networks might not be sufficient, especially for modeling complex interactions between variables with asymmetric dependencies. So third is hidden Markov model. HMM models or hidden Markov models are statistical models that are used for model sequencing and observing various variables whose underlying states are hidden or not directly observable. So they are widely applied in speech recognition, biometrics or bioinformatics, and natural language processing for modeling sequential data with the uncertain state transitions. So, what is fuzzy logic and how are fuzzy logics used for handling uncertainty? So, fuzzy logic it allows for representation of imprecise or vague information. So, fuzzy sets and membership functions are used to assign degrees of memberships to elements. So fuzzy rules and fuzzy interference engine enable reasoning and decision making in uncertain domains. And fuzzy logic helps in handling imprecise data. That is, traditional logic relies on crisp binary values, that is true or false, whereas fuzzy logic allows for degrees of truth. This is particularly useful for dealing the data that's not clear cut and it contains ambiguity or imprecisions. So second is fuzzy logics that are also used in linguistic variables and fuzzy sets. So fuzzy logic uses linguistic variables and fuzzy sets to represent vague concept lingually. For instance, a term like hot, cold, fast, and slow can be represented in fuzzy logic to capture their inherent uncertainty and subjectivity. Yeah. So third is membership functions. So fuzzy logic employs membership functions to assign degrees of membership to elements in sets. Instead of strict categorization, membership functions enables the gradual transition between being the member or not, allowing for more nuanced representation of uncertainty. So, how is artificial intelligence you approaches for uncertain knowledge representation? So, first is probabilistic reasoning. Probabilistic graphical models such as Bayesian networks, Markov, and hidden Markov models are extensively used to represent uncertain knowledge. These models relationship between variables probabilistically, allowing for reasoning under uncertainty. So fuzzy logics. Fuzzy logic is employed to represent and reason with uncertain or imprecise information. It enables the representation of uncertain through linguistic variables and fuzzy sets, allowing for approximate reasoning. So third is ontologies with uncertainty. Ontology augmented with the probabilistic extensions or fuzzy logic can handle uncertain knowledge representations. So these ontology allows for explicit representation of uncertain in relationships between entities in the domain. So fourth one is Bayesian network in AI planning. So Bayesian networks are integrated with the artificial intelligence planning systems to model and reason about uncertain states, actions, and outcomes. The incorporation of uncertainty helps in decision making under partial observability. So, what is evaluation and validation of uncertainty? Knowledge representations. Metrics such as accuracy, precision, recall, and F1 score can be used to evaluate the performance of uncertain knowledge representation. Cross validation techniques can assess the generalization and of the model, and real world testing and user feedbacks are crucial for validating the effectiveness of uncertain knowledge representations. So, what are the application of uncertain knowledge representation in advanced artificial intelligence? So, autonomous driving vehicles or systems rely on uncertain knowledge representations to navigate complex environments. So, healthcare systems can use uncertain knowledge representation to assist in diagnosis and treatment decisions. And financial prediction models can leverage uncertain knowledge representations to make informed investment choices. So, the conclusion is representing knowledge in the uncertain domain is crucial for advanced artificial intelligence systems to make accurate decisions. So, probabilistic models, fuzzy logics, machine learning, and hybrid approaches can be used to handle uncertainty effectively. The third conclusion is ongoing research and advancements will continue to improve the representation of uncertain knowledge in AI systems. Thank you for watching the video.